Okay, so I've got about 10 equations that we're going to do very quickly on this video. The idea is that you know how to solve equations. We're just looking at these two different situations, no solutions and infinite solutions. I've got a couple of regular equations so we don't forget that and we can see how they differ from these new style equations. But really, as far as why there's no solution or infinite solution, we'll see if I have time in this video. If not, I'll save it for chapter 5 when we actually get into graphing and it's a better situation to explain. You know the situation, get all your variables to one side because there's nothing to distribute and there's nothing to combine, so we go straight into that. The 1 would drop down. This becomes negative 5n, and there's that. Okay. And, you know, at this point, we just go and solve. And n would equal negative 3. What does this mean? It means that if I plug negative 3 into this equation up here, it would make a true statement. It would make both sides equal to each other. So that's not the new style of problem that I'm going to be showing you today. That's more of a review. And this is what you would normally see. We'll refer back to that in just a second. Now, this one, there's going to be something odd that's going to happen here. There is nothing to distribute. There's nothing to combine on either side, so I'm free to get all the variables to one side, and you know my preference is getting them to the right side. And this is where something funny is going to happen. Do you see right here? It cancels. But over here, it cancels. And the only thing that's left over is that I have one number left on the left side and I have one number left on the right side. There's nothing to combine because we've already taken care of that. And we would say this is a situation where there is no solution. We can go through every number in the alphabet. Excuse me, we can go through every number in the number system and it will not make this equation true. And if you want to know why, it's because this. If I take a number and I add negative 4 to it, it's going to be totally different than if I take a number and subtract 6 from it. See where they both got positive 3k on both sides, but we're doing different things to the 3k's? There's nothing that we can do that can make these two sides equal to each other. Let's go to number 3 real quick, and let's see about that. Do you see that I have a positive 6p here and I have a positive 6p here? Well, if I have 6p over here and I take 1 away from it, it's going to be a different number than what 6p is. But let's go through and solve it. There's no distribution here needed. There is nothing to combine, so we'll get all the variables to one side. This right here is an interesting situation, but we'll look at that in a second. This cancels, so the negative 1 drops. And this cancels, and nothing's left over there. But if this cancels as a placeholder, we'll just put 0 to say, hey, there's nothing there. Does negative 1 equal 0? No, so it's no solution. What I truly look for, though, is are there any variables left? No, there's no variables. And if I have two numbers left that are not the same, it's no solution. So let's take a look at this problem. Is there any distribution? No. Is there anything to combine? Yes. 2 minus 6 would make it negative 4b. All of this drops down because I can't combine, and now I can put them all to one side. Obviously this cancels here, but negative 4 plus 3 is negative 1. And now I can divide by negative 1. So this is a normal equation right here. We're saying that if I take 5 and plug it into this equation, it would make it true. Okay. If you notice, I actually had a variable left over. You know, after I swung this negative 3b, you know, after I canceled out by adding 3b, it canceled out of that right side, but it didn't cancel out on the left side. It just got me a new coefficient from the variable, and so something was there. Here, after I swung this over to the other side, there's nothing left on this side either, and so I just had numbers left over. That's the situation that I'm trying to get you used to today. Sometimes that will happen, and when these two numbers are different, it's no solution. So I guess it's time to show you what's going to happen when you swing it to the other side and there's just two numbers left and they're the same. So right here, well, first off, there's no distribution, nothing to combine. So now I can get all my variables to the same side of the equation. And this time I don't have any variables left over, but the number on the left side of the equation is the same as the number on the right side of the equation. This stands for infinite solutions. Now, you've got a Chromebook, look up the word infinite. You'll get an idea of what that is, and then if you're going, well, what does that really mean? Well, let's just say that the solution was 1. Well, 5 times 1 is 5, 5 plus 1 is 6. 5 times 1 is 5, 5 plus 1 is 6. So, yep, 1 could be the solution. Tell you what, let's try 2. 5 times 2 is 10, 10 plus 1 is 11. 5 times 2 is 10, 10 plus 1 is 11. Yep, 2 solved it also. This infinite solution right here, I can choose any number, and as long as I put it in for both of the ends, it will always be the same. But take a look at the actual equation. Yeah, I've got positive 5n on the right side, and I've got positive 5n on the, I'm sorry, this is the left side, this is the right side. They're the same on both sides. And what are we doing to the 5n on both sides of this equation? We're adding 1 to them. So no matter what I stick in there, it's going to be true because the left side is a mirror image of the right side. So that's the idea of infinite solutions. Now, why do I call it infinite? Because after I got down to this special point where there's no variables left, I had 2 numbers that were the same. And I go, oop, that's the rule to say infinite solutions. If I have 2 numbers that are left over that are not the same, I say it's no solution. So what about this one? I had 2 numbers that were not the same, no solution. And so you're just letting the problem drive you to this point. So let's try this one real quick. No distribution, no combining. So, okay. Just numbers left over, they're different, so that would be no solution. And by the way, the special symbol for that would be 0 with a line slash through it. Let's try this one real quick. No distribution, so let's go combine any like terms. Negative 3 plus 7 would be 4. Negative 6 plus 8x, let's go ahead and combine that. That would make it 2x. Let's go ahead and put a 1 in front of that x. And now 4 plus 3 would be 7. So I get 7 plus 1x equals 2x. Let's get everything over to the left side there as far as the variables. I'm pretty sure I said let's get everything to the right side at the beginning and then still took it to the left side, but it's getting late. It's been a long day. 1 minus 2 is negative 1x, and we'll deal with this in a second. And 2 minus 2 is 0. Well, um, well, let's just do this. Minus the 7, minus the 7. We'll go and solve. I really don't need a plus negative. We just need to drop that down like that. There we go. Just a regular old problem. 8. Distribution first. Bring everything else down that we didn't use. Now we can go and look for any combining. Nothing I can combine on the left side. Nothing combine on the right side. Let's get all the variables to one side. Almost made a mistake there. Almost said minus 16x. Regular problem there. So you see, as you go through and solve these, a lot of times you're really not going to know what you get until the end, and you just got to trust your instincts, do what you know best, distribute first wherever you see the parentheses, if you see the parentheses. Bring everything else down, make sure that you don't make a mistake. Hopefully I won't. After we do this, we want to combine. There's nothing I can combine on this left side of the equation, so now we turn our attention to the right side. And sure enough, I can combine these two. So all of this drops on the left side, untouched. This becomes 7x, and the plus 12 drops. Nothing I can combine, but I just want to draw your attention. Do you see this is 7x plus 12 on the left side, and this is 7x plus 12 on the right side? This will be an infinite solution. This is the infinite sign. Usually somebody's going, why? Well, let's just say the solution was 1. 7 times 1 is 7. 7 plus 12 is 19. Same thing over here, and we get 19. The two sides would be equal. Or if I said it was 0, well, this side would become 12, and if this was 0, after that multiplication, this side would become 12, and they're the same. So there you go. There's more than one solution to this equation, and because these sides are equal, pretty soon you'd figure out any number you stuck in for x would be the solution. But okay, let's go ahead and prove it. Minus 7x from both sides. No equation, or excuse me, no variable left over at all, and we've got two numbers left over that are the same. Yep, that's an infinite solution signature, I guess you could say. And again, you could put a sideways 8 for the infinity sign. Last one. We'll distribute. Hopefully that makes complete sense to you at this point. There's nothing to combine here, nothing to combine there. And after all of this work, we see that there are no variables. We have two numbers left over on different sides of the equal sign. They're not the same, so it's a no solution.